Welcome to Spring LIB.
For the following galvanic cell, let's calculate the concentrations of Ag plus and nickel 2 plus once the cell is dead. Let's start with our redox reaction here. Ag plus, add an electron, produce Ag solid. The E naught reduction here is 0.80 volts. And we'll have nickel solid being oxidized to nickel 2 plus and 2 electrons. The E naught oxidation here is equal to positive 0.23 volts. Multiply the reduction reaction by 2 so that we can cancel out the electrons. Our redox reaction is 2Ag plus. Add nickel solid to produce 2Ag solid and nickel 2 plus. The E naught cell value here is equal to 1.03 volts. So once the cell is dead, so when we have a dead battery, the E naught value is equal to 0. So E naught is equal to E naught cell minus 0.0591 over 2 log of K. We can plug in our values here and solve for the equilibrium constant. The E naught value is 0. E naught cell is 1.03 minus, this is N. Would be N here, 0.0591. N is equal to 2 for a transfer of 2 electrons, log of K, which is our unknown. So rearranging here, we get to 0.0591 over 2 log of K is equal to 1.03. Log of K is equal to 34.86, and taking the inverse log, we get an equilibrium constant of 7.24 times 10 to the positive 34. It's quite a large value of K for our equilibrium constant, because the value of K is large. The reaction goes to completion and the backwards reaction takes place. So we have 2Ag plus, add nickel solid to 2Ag solid and nickel 2 plus. This will change equilibrium, starting with 1.0 and 1.0 of each. Reaction goes to completion. This will be 0. So this will be minus 1.0 plus 0.5, and this will be 1.5. And then we have the backwards reaction. Initial change equilibrium, or we can just do this as change and equilibrium. This would be minus x plus 2x. This would be 2x and 1.5 minus x. The equilibrium constant here is equal to the concentration of nickel 2 plus over the concentration of Ag plus squared. We did solve for the equilibrium constant, which is 7.24 times 10 to the positive 34. That's equal to 1.5 minus x over 2x squared. We're going to assume that 1.5 minus x is approximately just 1.5, as x is negligible. Rewriting this, 7.24 times 10 to the 34 is equal to 1.5 over 2x squared. Solving this for x yields 5.18 times 10 to the negative 36. Therefore, the molarity of Ag plus from our ice table is 2x, which is 2 times 5.18 times 10 to the negative 36, and we get 4.6 times 10 to the negative 18 molar for the molarity of Ag plus once we've reached a dead battery. And the molarity of nickel 2 plus is going to be 1.5 minus x, which is equal to 1.5 minus 5.18 times 10 to the negative 36, which will remain unchanged, and the molarity of nickel plus once we reach a dead battery will be 1.5 molar.